So, hi everybody and welcome back to the C++ tutorial series for absolute beginners. This is video 263, and in this video we want to make an exercise about virtual function because we talk so much about virtual function, the theory part here on this side, and we finished it, but we have never made really practice exercises. So, and practice exercises is very important, and I hope you did it so far because I just talked too much, and now in this video I want to make an exercise. So what you have to do is just stop the video here, pause, and make a exercise, which is very important that you do it on your own so that you can see how much you understand it and how much you don't understand it, and then you can correct the mistakes and so forth. And in my case, I already created here an example because I want to not that you watch me typing, and now I explain just this example what I have, and I made a very basic example. You can see I created just a base class, and I have even commented it out a little bit, and then I called it fun. And then I have just made one public method in it, one function, and of course a virtual function at the start. And I have outputted here I have fun. And then I have made one derived class and another derived class, also very little. You can see super basic classes, just a class named games and an inherited public from the base class fun. And I just overwrite this virtual function, and you can see I have here another style. I wrote this virtual. This one you will never see in real coding because they omit it. Normally what they do in coding is this one they write. This is also optional, but they write this one to indicate yes, there is a virtual function in a higher hierarchy, and this one is an override about this virtual function. But I want to just show you that this one is legal. This is because, like I said, there is an invisible virtual here in front, so that's the normal thing what the compiler sees when he is doing when he is recognizing these functions. But the programmer just skips them. They skip even this sometimes, and that's not good because that's not readable. So we keep this one, and then you can see I just overwrite here. And I don't use a covariance because you can see I use the same return type, and we learned we can even use different return types in the derived class if it's a covariant, but we talked about this one, and I skipped this part here. I just use a normal override, and I do the same thing here, just virtual override again. Here I keep this with virtual override just so that you see all the different options here. And here is, of course, the only thing what I really change here is the text. You can see I have fun. This override with games, it says I have fun with games, and sports says I have fun doing sports. So that's it. And then about this function I will talk in a moment, but let's go down to our main. And then I just create objects. A fun object, this is the standard thing, just fun, base fun class, a games object, fun with games, a sports object, fun with sports. And then I demonstrate just a call. How we call this? Yes, this is just a normal object with a dot, and then I just call the functions which I have here separately. And what happens is they are calling normal. That's happening. But the question is now, wait a minute. We have talked so much about virtual functions and all this kind of stuff. Why is this useful again? Where we use it in practical use cases? And don't forget, I hope you have not forgot it that I said virtual functions can be used, for example, in function calls. Here is another function, and here I can call objects, and these objects, if they have virtual functions, they will be automatically called the right virtual function for us. What I mean with that, that sounds a little bit strange. Let's repeat this. So I have created here a function. You can see it has no return type. It's just called fun version. So one of this fun version I want called. And in the parameter list, I have made a pointer, because for virtual function we learned we need a pointer or a reference. Okay, I made here a pointer. And then called it fun param. And important is here what kind of pointer I made. I made a fun pointer, and fun is what? Is a base class, and the other ones are derived from this base class, right? That's very important here. And now this function here called fun version calls here just this one. It takes the variable fun param and it used the pointer call and just call have fun, which is this one here, right? And now again I go back to our main, and here on the bottom I have this call fun version, because it's just a method, right? A function. And interesting is now I can just put any pointer in it. First of all, I have to create this pointer object. So you can see I created here a fun pointer. This time I created a games pointer and then a sports pointer. I called them PTR. PTR stands for shortcut pointer, and then the same name like before, base fun class and fun with games and so on. And this one are just when we create a pointer, we have to assign an address to it. And so I assigned this address here to it. You can see it. This one is here. So this is just normal creating a pointer, but interesting is I use this pointer now just to call this function with this function calls here. So you can see call fun version ptr base class, then ptr with games, and ptr with sports. And interesting is here, first of all, what you should realize again, here I have this type fun. I can call it still with different types. We learned this is not normal, but in this case with inheritance it's working. I hope you remember this, because that's very important. In general, you have to assign here the same type or the compiler will complain. But in this case with virtual functions and inheritance, it is working. And important as well is because these objects here, which we created, these pointer objects, have virtual functions and overrides like here, it will call now all time automatically the right function. So for example, if I call here, let's start with the last one. If I call here ptr with fun with sports here, in this one, it will automatically call I have fun doing sports instead calling I have fun, like it says here with fun, because it is using again this virtual function call. Virtual function call means it starts here on top. This is the start point because here we have virtual, but then it checks, oh, this is not the final override. Then it goes here to the next class, because fun with sports here in this case is a sports class, and then it jumps to the sports derived class sports, which is in my case, where is this here, this one here, class derived, and then it checks this one and sees, oh, here is also a have fun method, and it is a override, and yes, this is the final override, and then I will use this one. So it is indeed using this virtual function call there. And when I start here my execution, you can see here on top I have this normal ones, this one here, the normal calls, and here on the bottom, this one here, are this function calls. Automatically it's using automatically the right one. Here on top I have all time specified the right class. You can see fun and then the right variable, and then call the right method in it. Here on the other side with virtual functions, actually I don't care. I just have a pointer to the class, and it will choose the right function based on virtual function calls. The second version here. This is one use case. Virtual function has more use cases, of course, and I hope you understand this a little bit. And I know we need a little bit more practice because this one is a little bit confusing, but not difficult, just a little bit more practice, because when we go back here to this example, what they show, they made all time these other examples. What I mean with these other examples, you can see they say you have to create here a base, derived base, which is just a base class struct in this case, and derived struct, and then they are creating a pointer or a reference in this case here to this b, but this is just normal. This is just normal. I think they made it here on the bottom. Yeah, let's watch this one here. Here again, a class base and then a derived from them. Then they create an object D, and then they are referencing this one. You can see we have a pointer, the address of D. And important on this one here, as we already discussed, this D here is normally a D class. This is this one, the derived class, but we are assigning it to a B pointer, and this is normally not possible, but I explained to you then that here happens an implicit cast. It is called an upcast from this one to here. That's why behind the scene, that's why it's working. And then we can also call here, you can see this virtual function call, which says, okay, this BB starts here, and then I know I come from here, so I will check also this one if this has an override. Yes, it has an override, so D will call B do F0. But this example here, what they are showing here, is more for understanding, I think, for practical use. You can use it too probably, but I think my example is also very good. And yeah, and there are other practical use cases where it comes in very handy situations. And there is one more thing what I wanted to mention, which is very important, that you're not confused when I say, I often said there is a start point in the base, right, with virtual. Careful, when I say start point virtual, that means not it must be in the base. And that's also a problem here. They also show all time that the start point is in the base, right, in the base class. That's not true. What I mean not true is this virtual indicates where the start point is. What I mean with that, let me show you this one in the graph here fast. So let's say I have here a class, this class, then I have here another class here. This class inherits from here. Then I have another class here. This class inherits from this one, but here this class has this word virtual. This class has not virtual. This one has virtual. That means here is the start point. If let's say we have here one more class, this one inherits from here, and this class here overrides this method here. So I override it. Oh, where? Right. Then it is overriding this one here to this virtual here. So, but important is to understand it must be not in the base class, because this one is my base class, but here is nothing virtual. Important is where the first time this word virtual appears, and then the overrides comes according to this one. And all the examples what we've seen so far, for example here, yeah, you can see it, they put it all time in base just for demonstration purposes. You start with the base class, there is a virtual keyword, and then the derived from it, and then there is an override. Careful, that must be not the case, like I showed you here in my diagram. There can be a base class, then it is inherit, and it starts here with virtual, and then only from this point on it will be override for this method here, and then so on. All right, I hope you understand this, and so on. So in my example, I could make this when I delete this virtual, then I have to override delete it, and then I could start here in my derived class, but then I need one more derived class here. yeah, I think you understand this. Important is it must be not in the base class. This like it says all time the base has the virtual. That's not the case. All right, then I hope you made some more examples, and of course you can also use let's see, that's not this. You can also use ChatGPT, and here I asked ChatGPT to make some examples, but you see ChatGPT makes also the standard examples from this CPP reference comes. Anyhow, you can see they have here a base class foo, it is printing something out and then inheriting from here and then just overriding this one. And then they make this one here with this base pointer, creating this one with new derived. So here again the base pointer is pointing to the derived class, and here is again internal implicit upcast later, and then they are using base PDR and then foo call, just pointer call, and it calls derived foo just through inheritance. All right, they are doing this, and of course new with delayed base PDR, but this one here is not right, I think. Yeah, because it's not wrong, but there is something very critical here, which is if you see it, you are good. What is here critical about this one? It's very difficult to say actually, because we have not discussed this. I said we skipped this. That was this this virtual destructor call, and there can be a problem here with this destructor call. You can see here is a base B, delayed B. It calls derived, which then it can here make a problem if we have not a base constructor, and ChatGPT is as presenting a function without a virtual destructor. Yeah, that's not a good example, I think. You can read this one here, because why it's not a good example, because this one here, read this part here, and you will understand that this one can cause big problems with this example. But we have not talked about it, so don't worry. This is only something to do with allocating. Here we allocate a new allocate memory, and we use delayed pointer. But this pointer, the destructor call, will only I think delete the base and not the derived one, and that's why it's a problem here. But not sure, you have just to check this out. But yeah, careful about these examples from ChatGPT. They are not totally wrong, but sometimes not so perfect. So check them all time. The best thing is you are just checking them and so on. Or you are just finding other examples from the net, or use just good C++ books and so on. All right, with that said, I think I stop here and hope that you are doing more examples to train this and all these other things. Also, perhaps with this covariant is also interesting, confusing for many people. Not because it's difficult, just because there are different type in a function, like in my example. That's also a little bit confusing when you see this one first time. We expect a fun, and I put a games variable with a type game in it, or sports. Then a starter would say, hey, what's going on? That's not possible. Yes, it is possible, because it's a virtual function call. And yeah, that's very important. I hope you understand it so far, and with that said, I stop here. And if you have any questions, like all time, write in the comment section. See you in the next video. Bye, good luck, and have fun.